This is question number 5, and I'm now question 4. I used a slider, so I'm now going to go back into main. But in main, I'm now going to go clear all variables because B will equal the last value that B equaled on that slider. So B has a value of 100. So what I'd like to do is to go edit, clear all variables, okay, and now my B is available to be used, and it's B. Okay, so I have an expression which is variables. Okay, so state the equation of the inverse. Okay, so if I go make the x, y, and I get g inverse of x equals log base e of x plus 3 on a. Find the coordinates places between g of x when a equals 3. Intersection points. Okay, so when a equals 3, and it's decimal places, so that's there, that's there. Analysis, G solve, intersection, I've got negative 2.82, and the second one looks like 0, 0, and it is. Find it when it's equal to 10. So when that's equal to 10, they're unknown. So state the exact value of A that will give only one intersection point. So if at this one there are no intersection points, but on the previous one we had them intersecting twice, and then the next one they don't intersect at all, there must be a value of A where they just touch. And that's what this question is asking. Okay, from our notes, this refers to what we talked about as being kissing functions, where exponentials and logarithms just touch. And in our bound book, we should have these rules. We can set the y values equal to each other, or we could set them equal to x, and we can set the derivatives, or one of the derivatives, equal to 1. So I'm going to take equals 1, and I'm going to solve that for x and a. So what am I saying? I'm saying f of x has to equal x, because at this point here, the line of x also goes through, and the curves are equal to, so g of x equals the inverse, or g of x equals x, or the inverse equals x, because there's 3 curves going through that point. And because the gradient has to be 1, I can now solve that, and I get an a value of e squared. And I'll just double check. If I have f of x and I go analysis and I sketch it, and then I go analysis, sketch the inverse of the black one, and go xe, and I go zoom in on that area there. The black one has its inverse that just touches.